Hello and welcome back to SparkVise. Today we're going to be looking at one of the key features of the course and of every computer ever. This is the CPU. We're going to look at what the CPU is, how it works, and including a brief look into the fetch, decode, execute cycle. Please drop a like and subscribe for more content like this. Let's get on into the video. So the CPU is often referred to as the brain of the computer, because it's responsible for processing all data and executing instructions. It plays a critical role in ensuring that the computer system functions correctly. The CPU performs all calculations and logical operations, allowing software programs to run efficiently. It also controls and coordinates the operation of all hardware components, ensuring they work together seamlessly. Every program and every piece of data processed by your computer must go through the CPU. Whether you're browsing the internet, playing a game, or editing a document, the CPU is actively managing all these tasks. CPUs aren't limited to traditional desktop or laptop computers. You can find them in almost all modern digital devices. That's smartphones, tablets, smartwatches, gaming consoles, and embedded systems such as those in cars and household appliances. In the next section, we're going to take a deeper dive into how the CPU functions, looking at its core components such as the control unit, arithmetic logic unit, and the registers, and how they work together to execute instructions. The CPU consists of 6 main components, each with a crucial role in ensuring the efficient processing and system control. These components are the control unit, arithmetic logic unit, registers, cache, buses, and the clock. For GCSE, you don't need to know much about buses. The main thing we're going to focus on are the units, the registers, cache, and clock. All of these work together to process data, execute instructions, and manage hardware operations. Now, let's go through each one in detail. The control unit, or CU, acts as the coordinator of the CPU. It ensures all tasks are carried out in the correct sequence. The CU is responsible for fetching instructions, decoding them to understand what needs to be done, executing the instructions by issuing control signals. So that's telling other components of the CPU what needs to happen, so allowing the computer to process data, and managing the flow of data within the system. So it's kind of, we can look at it as like a traffic controller. It ensures that the data moves swiftly, smoothly, and efficiently through the CPU. Next, we're going to look at the arithmetic logic unit. This is where all calculations and logical operations take place. The ALU has 2 main functions. Number 1, performing arithmetic operations. This is everything that's like a maths-based operation, so addition, subtraction, multiplication, and division. The second role of the ALU is logical decisions, comparing values using conditions like greater than, less than, or equal to. So every comparison operator we look at, as well as our and, or, and not. The ALU also acts as a gateway between primary memory, the RAM, and the secondary storage, such as hard drives or solid-state drives, to ensure that the data moves between them when needed. Another component of the CPU is cache and clock. Cache memory is small but extremely fast type of random access memory built into the processor, storing frequently used instructions and data. We look at cache a lot more detail in later slides when we're talking about CPU performance. It stores frequently used instructions and data, reducing the need to fetch them from the slower main memory. This results in significantly faster processing times. We can think of it as a short-term memory bank that the CPU can access almost instantly, improving overall efficiency. Finally, the clock keeps everything running in sync. It generates pulses at this constant rate, ensuring all operations happen at the same time. The speed of clock is measured in hertz, which determines how many instructions per second the CPU can process. This is how many fetch, decode, execute cycles are happening per second. A higher clock speed generally means a higher CPU performance, and again we'll touch on that in more detail in the CPU performance video. Another main part of the CPU are registers. These are small high-speed memory locations within the CPU. They store data temporarily while processing is happening. The main types of register are the program counter, or PC. This stores the memory address of the next instruction. The memory address register, or MAR, which holds the address of a location in memory. The memory data register, or MDR, which temporarily stores data being transferred to or from memory. And the accumulator, which stores the intermediate results of calculations and logical operations. To go back over that, because that sounds complicated and lots of words, program counter stores the next address that CPU needs to go to. MAR holds the address. Memory data register holds the data, and accumulator holds the result of a calculation from the ALU that we've just talked about. So they are small pieces of memory that can hold little bits of data temporarily. Registers play a crucial role in ensuring data is readily available for processing without unnecessary delays associated with reading to and from main memory. So a quick recap. The CPU is made up of several key components, including the CU, ALU, registers, cache, and a clock. Each one of these plays a vital role in executing instructions, managing data flow, and ensuring your computer runs smoothly. Understanding these components is essential for anybody studying computer science or just curious how computers work. If you found this video helpful, don't forget to like, subscribe, and drop a comment below if you have any questions. Thanks for watching, guys, and I'll see you in the next one.